Hello friends, in this quarter we are going to learn what are the quadratic equations, how to find the root of a quadratic equation, what is the meaning of root of a quadratic equation, and we are going to learn a very effective and innovative method of finding the root of an equation by first finding midpoint of the root and then reaching to the root on either side of the quadratic equation. So here we go. Now let us suppose that we are having a quadratic equation of the form ax square plus bx plus c equal to 0. In Maple, you can write down a command, solve equation 1 for x, and you can obtain the two roots which we have learned somewhere in the middle school. It is minus b plus minus under root of b square minus 4ac upon twice a. Now, for some advantage, we are going to change the form of this equation ax square plus bx plus c equal to 0 in the way ax square equal to mx plus b. We are dividing the equation by a, then we are taking bx plus c on right hand side, and b by a we are writing m, and c by a we are writing m. So the leading coefficient of x square is unity. That's a point of interest. Now we can rewrite that as y equal to x square and y equal to mx plus b. So here what we have done, we have split our equation into two components and we have equated that with y, and we have had two equations. One is representing a line mx plus b is a line having slope m. This red line is indicating that line mx plus b, and b is the intercept of the line on y-axis. Now, if we try and solve this equation by the earlier formula, we can obtain these two roots. But what that root means? If we substitute value of x, the equation will be satisfied. That's for sure. Now, y equal to x square, we are going to plot this part, y equal to x square. So that represents a parabola with vertex at origin, which is represented by this green line. Now, y equal to mx plus b and y equal to x square, they have intersection at 2 points. One point we are going to call as x1 and another point we are going to call as x2, and in fact these x1 and x2, they are roots of the equation. So mathematically they are represented here. One is with plus sign, another is with minus sign. Now quickly we shall reach to an example wherein we have a real quadratic equation with all numerical possible values, in the sense that x square minus 3x plus 2 is equal to 0. So this equation we can enter in Maple and we can ask Maple to solve this equation. It will return values of the roots of the equation. So if you substitute value 2 in this equation, this will be balanced, and if you substitute another root x equal to 1 in this equation, the equation will be valid for that point also. Now, if we try to plot this in Maple, you will be able to see that the curve which is representing this equation will have x intersection, will have intersection with x-axis at x equal to 1 and x equal to 2. So what is the meaning of a root? Root of an equation is, the quadratic equation is intersecting x-axis. It is quadratic equation is intersecting x-axis at two places, so we have two roots. Now we shall rearrange this equation. such that x square minus 3x we have kept on left hand side, and this we shall assume y, and we shall transfer these two on right hand side. It will be with minus sign. So x square minus 3x equal to minus 2. This we have equated with y, and now we can plot two functions. The first function is y equal to x square minus 3x, and second function is y equal to minus 2. Now we can explore the command plot x square minus 3x, and we are having a simultaneous plot of two entities, y equal to minus 2, y equal to x square minus 3x in the range 0 to 3. I priorly know that I am interested in this only range wherein I can see the graph nicely and look at the intersection points. Now, here you already know that it has roots 2 and 1. If we rearrange this equation and try to visualize that the point of intersection of these two graphs is 1, x equal to 1 and x equal to 2. So these are the roots. So the two entities, one is parabola, another is a line. They intersect at 2 points, and those are the roots. Similarly, you can rearrange the same equation in a way that we have one quantity x square, another quantity 3x minus 2, and then plot that. You will be able to see two curves again intersecting at 2 points. This point corresponds to 2 and this point corresponds to 1. So obviously we are knowing the basic equation and their roots. Similarly, you can hunt out another form in which x square plus 2 you have considered, x square plus 2 we are considering on one side, and minus 3x is shifted on right hand side, it will be plus 3x. So we can plot these two entities together in the same range, x rolling from 0 to 3. You will be able to again see that at x equal to 1 and at x equal to 2, these two curves are intersecting with each other. Now we can have a look at all possible combinations, and here you will be able to see roots 1 and 2, they are reflecting by default. That is the graphical meaning of roots of an equation. Now we are looking for another equation where a is 1, b is minus 3 and c is plus 3. So you can explore b square minus 4ac, that returns value minus 3, and then you can find out two roots. The roots appearing by the formula are 3 plus minus under root of minus 3 upon 2. So the equation will appear like this. We can ask Mapple to solve this equation and it will return us roots of the equation as appearing here. So this is very obvious thing. Those who are acquainted with complex numbers can understand the complex roots, where I want to mention that this I represents under root of minus 1. In Maple, capital I is reserved for under root of minus 1, which usually we write as small I, and that has value under root of minus 1, which can not be further simplified. Now, if we try to plot this graph x square minus 3x plus 3, then you will be able to see that this graph is not intersecting, this curve is not intersecting with x-axis. This is a quadratic equation and this is not having any intersection with x-axis. There is no possibility over all range of values of x that the graph will intersect with x-axis. Still, this equation has roots, and now these roots are imaginary roots. You can very well identify this. So this is the graphical scenario where the roots, the real roots are not existing. Then graphically the curve is not touching your x-axis. Now, if you try all variants like we have done earlier in earlier example, then you will be able to see that this curve is not being intersected by the combinations. Here I have done a clumsy plot in which all curves are represented so that you can quickly understand this. You can pause the video and have a closer look at this. Now, we shall understand this method of midpoint finding, and then from midpoint we can reach to the roots of the equation. Let us suppose that x1 and x2 are the roots of equation. I am talking about quadratic equation. So x minus x1 into x minus x2, I will be able to raise my quadratic equation with this, and that is what I am doing. If you expand the bracket, you will come across x squared minus inside the bracket x1 plus x2 into x plus x1 x2. Here x1 plus x2 I am replacing by alpha, and x1 x2 I am replacing by beta. That makes me a compact representation of the formula x squared minus alpha x plus beta equal to 0. So instead of this way of representation, I would prefer x squared minus alpha x plus beta equal to 0, this way of representation. I want to very clearly mention that the leading coefficient of x squared should be unity, and then only this method will be in the same form as we are representing here. So here, to make this form, you can employ these equations. Now alpha and beta are known numbers. If we are handling an equation x squared minus 6x plus 8 equal to 0, then obviously alpha is 6, beta is 8, and these are the known numbers. What is unknown is x1 and x2, which are roots of the equation. Now we are interested in hunting out x1 and x2 for the given quadratic equation by midpoint method. Now let us suppose that alpha and beta are known, and for reference I am leading this problem with an example x squared minus 6x plus 8 equal to 0, so that alpha is 6 and beta is 8, where alpha is x1 plus x2, but I am not knowing x1 and x2, and beta is x1 into x2, I am not knowing x1 and x2. I am going to explore these formulas for finding x1 and x2. Now let us consider a number line. On this number line, we have a quadratic function that rolls like this and that possess roots. The roots of the equations, roots of the quadratic equation will be at these 2 points. Now we are interested in finding x1 and x2. However, midpoint method will offer us the midpoint expressed by x1 plus x2 upon 2. So the midpoint formula will be able to tell me the midpoint of the two roots, and I'm already knowing alpha, so I can find alpha by 2 and immediately I will reach to the mid of the root. So in this case alpha is 6, so midpoint is 3. Now I can travel equal distance on either side so that I can reach to the first root x1 and second root x2. So that distance I am going to cover on either side is equal. I can represent that by u. Now the roots are x1 will be 3 minus u. We are going a step u before midpoint, that is before 3, and distance u after 3, that is on right hand side. So x1 is 3 minus u, x2 is 3 plus u. Now the two roots in general can be alpha by 2 is the midpoint, so plus minus u will lead you to the root. So I can employ the second formula, beta is equal to x1 into x2, and beta is known to me. So x1 into x2 is equal to 3 minus u into 3 plus u. So x1 into x2 will be, this is a minus b into a plus b, it will be a square minus b square, so it will be 9 square minus u square, and here beta is known to us, that beta you can employ. So u square in general will be 9 minus beta. Now here u square is equal to 9 minus beta, and beta is 8, so you can replace beta by 8 and you will be able to find u square is equal to 1, and then you have to find u is equal to square root of 1, that is 1. So most difficult part is here. If you encounter with some number, you have to obtain root of that equation, root of that number. So here, as you know you can plug in the value of u here and here, so that you can obtain the root. So 3 minus 1 is 2 and 3 plus 1 is 4. So the roots are 2 and 4. So this is a very simple method. When you will employ it to a problem, you will be delighted to see how quickly we arrive at the root of equation, or the roots of equation. Let us explore the equation x square minus 3x plus 2 equal to 0 for finding roots of the quadratic equation by midpoint method. Now here alpha is equal to x1 plus x2, and alpha you can identify, it is 3, so midpoint is 3 by 2. So you identify a number line on which the point 3 by 2 is of our interest, and then we have to go u interval on both sides so that you can arrive at the root, where the roots are expressed by 3 by 2 minus u, 3 by 2 plus u, and the whole issue is now of finding u. That is very simple. So two roots we can employ, x1 into x2 is equal to beta, and we already know that beta is equal to 3. So 3 by 2 minus u into 3 by 2 plus u is equal to 2. So here we are borrowing this value of beta from the equation. Now a minus b into a plus b will be a square minus b square. So 3 by 2 square minus u square is equal to 2. So you have to flip these two terms so that you can obtain equation for u square, and u square will be 3 by 2 whole square minus 2. So 9 by 4 minus 8 by 4, LCM we have made identical. So u square will be 1 by 4 and u will be 1 by 2. The moment you obtain u, you can employ in this place so that you can find out the root. So 3 by 2 minus u, u is being replaced by 1 by 2. 3 by 2 plus u, again 1 by 2. So 3 by 2 minus 1 by 2 is 1. 3 by 2 plus 1 by 2 is 2. So 1 and 2 are the roots of the equation. Let us try some hands-on experience on another equation, x square plus 4x plus 4 equal to 0. You have to compare this equation with our standard format and identify alpha is equal to minus 4 and beta is equal to 4. Now x1 and x2 are our roots, and alpha is equal to x1 plus x2 and beta is equal to x1 into x2. Now we want to identify midpoint of the two roots x1 and x2. So by midpoint formula, it is x1 plus x2 upon 2, that is alpha upon 2, and alpha we know it is minus 4. So minus 4 by 2 will be minus 2. Then we have to identify minus 2 point on the scale, and we have to uh, travel distance u on either side of minus 2 so that you can reach to the root of the equation. So this is x1 root and this is x2 root. So minus 2 minus u, minus 2 plus u. So these are x1 and x2. Now we shall explore this equation beta is equal to x1 into x2. So minus 2 minus u into minus 2 plus u. This is equal to 4. Value of beta we are substituting 4. So a plus b, a minus b will be a square minus b square. So minus 2 square minus u square is equal to 4. So here we can flip the terms so that we can find the unknown thing, that is u square, which is equal to 4 minus 4, that is 0. So as u square is equal to 0, u is also 0. So we can write two roots as we have devised here. Minus 2 minus u, minus 2 plus u, and u is 0. So here we are arriving at a single root of the quadratic equation. And if we really plot this quadratic equation, you will be able to see that this graph touches x-axis at minus 2, offering us a single root of the expression. Now let's roll through the fourth example, x squared minus 4x plus 5 equal to 0. You have to compare this equation with the standard form that we have started with and find out alpha and beta. Here alpha is equal to 4 and beta is equal to 5. Moreover, alpha is x1 plus x2 and beta is x1 into x2, where x1 and x2 are roots of the equation which we are trying to find. Now midpoint of the roots will be x1 plus x2 by 2, which is in fact alpha by 2, and alpha we know it is 4. 4 by 2 will be simply 2. So on the number scale you have to identify number 2 and you have to jump distance u on left hand side and u on right hand side so that the roots will be 2 minus u and 2 plus u. Now once you know that 2 minus u is x1 and 2 minus u is x2, we can find out beta is equal to x1 into x2. Beta we already know it is 5 and x1 is 2 minus u, x2 is 2 plus u. So a minus b into a plus b will be a square minus b square, that is 4 minus u square is equal to 5, and you can rearrange this equation for u square, and u square is minus 1 and u will be under root of minus 1, that is I. So you have to employ u in the basic equation of roots 2 minus u. You have to replace u by I. 2 minus I, 2 plus I will be the roots of the equation. And if you plot this in Maple using the equation we have started with, you can see that this is a parabola opening upwards having vertex at x coordinate 2, y coordinate 1, and you can clearly see that this is not touching x-axis, therefore it is not having real roots, it possesses imaginary roots. Now fifth example, I have randomly picked up an equation x squared minus 7x plus 9. So here you can again compare with our standard equation and identify alpha is equal to 7, beta is equal to 9. Now midpoint will be x1 plus x2 by 2, where we know alpha, we are replacing x1 plus x2 by alpha, and we'll be exploring later on beta is equal to x1 into x2. So alpha is known, 7 by 2 will be the midpoint. So here you can identify the point 7 by 2 on your number scale and go u interval to the left and to the right, so that 7 by 2 minus u, 7 by 2 plus u will be the two roots x1 and x2 of the given equation. The only part is we are left to find out u, and beta is equal to x1 into x2. We are exploring beta, we already know it is 9, and the product of two roots 7 by 2 minus u, 7 by 2 plus u will can be solved for u, and 49 upon 4 minus u square is equal to 9. So here the only toughest part is to find square root of u. Here you can rearrange the equation for u square, and u square is 13 by 4, and u is equal to under root 13 by 2. Now the roots of the equation are 7 minus under root 13 by 2, 7 plus under root 13 by 2. Now if we plot this quadratic equation, x square minus 7x plus 9 in Maple, will be able to see that this curve cuts x-axis at 2 points. So this point and this point, something below 2 and something above 5. So numerical value of it can also be obtained using calculator or any other method. Thank you for your patient hearing.